Welcome. In today's explainer, we're taking a deep dive into the hidden communication layer of the internet. We are going to completely demystify exactly how digital systems talk to each other. And honestly, by the end of this, you won't just know what an acronym stands for, you're going to understand the underlying architecture of almost every single piece of software you touch today. So let's get right to it. Okay, let's dive into this. Have you ever actually stopped to wonder how massive, complex apps like Uber, Instagram, or Amazon function under the hood without, constantly crashing? Because we experience them as just one smooth single application on our phones. But in reality, they aren't single applications at all. They're dozens, sometimes hundreds, of entirely separate systems that constantly need to talk to each other in real time. Think about it. If we didn't have a standardized, structured way for all these separate systems to communicate, it would be absolute chaos. Everything would have to be tightly coupled, every single piece of code would be dangerously intertwined with every other piece of code, updating anything would be incredibly slow, and it would be practically impossible to scale up to millions of users. So, the solution to this massive scalability nightmare? The API, or Application Programming Interface. It's the essential bridge that lets these independent systems actually talk. All right, let's break this down with our first core concept, the waiter analogy. Picture yourself sitting at a nice restaurant. You're the user, right? The client. You have an order you want to place. But you don't just walk into the kitchen and start yelling at the chefs or digging through the fridge. Instead, you talk to the waiter. The waiter takes your specific order, that's the client request, and physically walks it back to the kitchen. The kitchen, which acts as our back-end server, does all the heavy lifting, the cooking, the data processing, and once the food is ready, the kitchen gives it back to the waiter. The waiter then delivers your food, which in the digital world is usually a neat little package of data called a JSON response, right back to your table. The waiter is the API. Software engineer Ashish Pratap Singh actually hit the nail on the head here. He says, think of an API as a middleman that enables applications to interact without needing direct access to each other's code or database. This is absolutely crucial. The API protects the kitchen. It means the kitchen can completely change its stoves, swap out its pans, or hire entirely new chefs, and as a customer, you literally don't need to care. As long as the waiter still takes your order and brings your food, the whole system works flawlessly. So let's map that analogy onto actual software architecture. System architecture, front-end versus back-end. Now, what's really interesting here is the clear dividing line. On the front end, this is the menu you read and the table you sit at. It's the graphical user interface, the polished buttons and screens where absolutely no coding is needed by the user. But on the back end, that's the kitchen. That's where the heavy data processing, the complex business logic, and the databases live. And APIs, they sit right in the middle, running on those back-end servers, constantly carrying requests from the shiny front end over to the heavy-duty back-end databases. Let's look at a real-world example, like Uber. When you open the Uber app and hit Request Ride, you aren't just sending one simple message. The moment you push that button, your front end fires off multiple waiters, multiple API requests, all at once. One API request arrow races off to the server to find nearby drivers. Another API calculates the exact fare and routes. Another spins up real-time tracking. And yet another handles the secure payment processing. The app on your phone is essentially just an empty shell. It's a collection of APIs with a really polished user interface layered on top. So who actually gets to use these digital waiters? Let's move on to the types of APIs. We basically have two main categories here. First, open APIs, or public APIs. These are like a restaurant offering takeout delivery to absolutely anyone. YouTube, for example, has a very public search API. External developers can send a request with a keyword like, say, machine learning tutorial, and YouTube's API will gladly return a structured JSON response with titles, descriptions, and video thumbnails. But contrast that with internal or private APIs. Think about when you buy something on Amazon. Multiple independent microservices, order processing, inventory checking, logistics, they all use internal APIs to talk to each other. These are strictly locked down. You can't just access Amazon's internal inventory API from the outside. They only serve the internal company systems to ensure massive scale and tight security. Oh, and just briefly, it's definitely worth noting that not all APIs travel across the web. Some exist purely inside the code itself. These are code interfaces or library APIs. Think of Python's built-in sorted function, or using TensorFlow for machine learning. You feed them raw data and they return complex mathematical outputs without you ever needing to write the underlying algorithms yourself. They still follow the exact same rule of taking a defined input and returning a predictable output, just without the network trip. Okay, so how exactly do these systems package their data? Let's get into how APIs communicate. And this brilliantly illustrates the evolution of how systems actually talk. REST is by far the most common today. It uses simple, lightweight HTTP calls and usually sends data back in easily readable JSON text. Super straightforward. But if you're, say, a huge bank needing strict security and rigid structure, you might use SOAP, which is an older method that relies on strict XML files. Then we have modern solutions like GraphQL. Instead of making multiple trips to different endpoints to get what you want, GraphQL lets the client ask for exactly the data they need in one single request. And finally, gRPC, built by Google. Instead of sending text back and forth, gRPC uses binary data. It is incredibly fast and highly efficient, literally perfect for internal systems that need to communicate in microseconds. All right, enough theory. Let's see this in action. The mechanics in practice. It's actually a really straightforward visual flow for a developer. Step 1, you find your API, say OpenWeatherMap, for pulling live weather data. Step 2 is absolutely crucial, authentication. You can't just spam requests all day, you need an API key. This is exactly like showing your ID to the waiter so they know exactly who to bill. Once you securely grab your key, you move to step 3, testing. Before writing a single line of code, developers use tools like Postman to visually send a request out and look at the raw data that comes back, just to make sure the connection actually works. And once it's tested, writing the code is beautifully simple. Using a language like Python, it often boils down to literally just 2 functional commands. Requests.get sends the arrow out to the server. Then, response.json grabs the data that the waiter brings back and converts it into a usable format for your application. That's it. All the insane complexity of the backend is totally hidden behind those 2 simple actions. But of course, sometimes the waiter drops the plate. APIs don't always return perfect responses, and robust apps have to be designed to catch these errors gracefully. If you send the wrong input, you might get a 400 error for a bad format. If your ID is expired, you'll see a 401 error, unauthorized. If you ask for the weather in a city that literally doesn't exist, you're gonna get the classic 404 not found. And if you ask the waiter to run back and forth too many times way too quickly, you'll hit a rate limit error. Handling these exact codes is a massive part of a developer's day-to-day job. So we've gone from simple analogies to actual code. Let's wrap this up with the big picture and your career. Why does all this matter? It matters because understanding this communication layer is the absolute key to the modern tech industry. Whether you want to move into backend engineering, design microservices, or work in cloud computing, APIs are the foundational building blocks. Every single cloud system, every automated CI/CD pipeline, and every DevOps tool you will ever touch depends heavily on APIs to function. When you understand the API, you truly understand the nervous system of the entire internet. As Petar Ivanov noted in a great discussion about this very topic, without APIs, it will be hard to scale and design robust apps. And that is the fundamental truth of modern software, right there. We decouple systems so they can grow independently, and we connect them with APIs so they can seamlessly function as one. You've seen the massive problem tightly coupled systems create, you've met the digital waiter that brilliantly solves it, and you've seen the protocols they use to pass data back and forth at lightning speed. Now that you finally understand how all these massive apps communicate internally, the only question left is, what system will you build next? Thanks for joining me on this explainer. Keep learning, keep building, and I'll see you in the next one.